Hello everyone, this is Chapter 3, Section 2, Part B. Today we're going to be learning about density. So the density is simply the relationship between an object's mass and its volume. And this will let you figure out if it will float or sink. So to determine that, to find your density, you would take your mass and you divide it by your volume. So when a mass is measured in grams, so we usually use grams, and the volume is in cubic centimeters, then the density is going to be given the units of grams divided by centimeters cubed, or grams per centimeters cubed. Whenever you're looking at the SI unit, you use kilograms per centimeter cubed. That is also a possibility. A third possibility is grams per milliliter, and we'll be using this one in class, where you find the grams so you find grams by using a balance, and then you divide it by the milliliters, which you find by using a graduated cylinder. Once you've found that density, you can actually compare different substances, and that will allow you to determine if something will float or if it will sink. So here it tells you that you have weighed this amount of a cube of lithium. It weighs 10 grams and it takes up a volume of 19 centimeters cubed. When you divide that out, you get 0.53 grams per centimeter. As you go down the line, you'll start to see water has a higher density of 1 gram per centimeter cubed. And then you get an even more of an increase, which is 2.7 grams per centimeter cubed. And finally, you get something called lead, which is going to have a density of 0.88 grams per centimeter cubed. Now notice how the amount that they weigh is all the same for each one of these blocks. However, the amount of space they all take up is very, very different. And that's what results in the different densities. Because of these different densities, liquids are going to separate into layers. And additionally, whenever you put something into a liquid that is a solid, you can determine if it should float or if it should sink. So to the right here, I have a beaker full of different liquids. Oil is on the very top, and it's going to float on water, which is the green layer, because it is less dense. So it has a density that is less than that of water. Then you have something called corn syrup. It's very similar to the syrup that you see in your fridge that you put on pancakes in the morning. And that is going to sink. And the reason for that is it is more dense than water. So a great example that I could use on a test would be to give you 3 different densities. And you have to determine what floats. Here is a example of the different densities of some common things that you may run into. You do not need to memorize. Again, you do not need to memorize this chart. So do not memorize. However, it does show you some great examples of how to compare different densities. So here's water. Water is usually the baseline because it has this nice number of 1. Things that are more dense, So that would be the stuff up here. Those are all going to sink when placed in water. Things that are less dense are going to float. So you should definitely understand what is going to sink and what is going to float. So make sure you understand that sinking things are going to be more dense, whereas floating things are less dense. I'd write that down right now. Go ahead and take a second to pause the video. So as the temperature increases, that does change the density of the object. The volume of most substances, whenever they are heated, are going to expand. So think of in the summer, whenever it's really, really hot, your fingers probably expand. The same goes for pretty much all substances. Since we have the ratio of mass over volume, when your volume gets bigger, what's going to happen to the overall density? So let's try one out. If I have a mass of 10 grams and it has a volume of 10 milliliters, its original density would be 1 gram per milliliter. But let's say I heat it up. You still have 10 grams. Your mass doesn't change just because you get warmer. However, your volume may increase to 15 milliliters. This is going to change our density to 0.66 grams per milliliter. That has caused the density to go from 1 gram per milliliter and decrease to 0.66 grams per milliliter. So, therefore, the density of a substance generally decreases as the temperature increases. Let's take a try at this example problem. So, a copper penny has a mass of 3.1 grams and a volume of 0.35 centimeters cubed. What's the density? So let's write down what we know. I like to write it out as follows: dmv. All of those, this is density, the m is for mass, and v is for volume. Do we know the density? Nope, that's a big question mark. Do we know the mass? Yep, tells me right here that it is 3.1 grams. Do we know the volume? Why, yes, we do. 0.35 centimeters cubed. Now, you will need to know that density is equal to mass divided by volume. Okay, so do we have the mass? Check. Do we have the volume? Check. Let's plug in those values. So density is going to equal 3.1 grams divided by 0.35 centimeters cubed. When I plug those numbers into my calculator, I get this nice long number here. I didn't even write all of it out. But let's see how many of these numbers we are allowed to keep that are significant. So if you remember our division rules, we can keep the sig figs which match the least number of significant figures in our numbers that we plugged in. So our top number has 2 significant figures. Our bottom number has 2 significant figures. So our answer can have 2 significant figures. Therefore, let's see. We have our first 2 are going to be marked right here. We're going to look to the right, and it is 5 or above, so that causes our number to round up. So our final answer would be 8.9 grams per centimeter cubed. And if you want that all drawn out for you, Again, we have those here in the PowerPoint, which is also online. So, with that information, can you assume that something with a low weight will float in water? So let's think about this. Do we know the weight? Does that help us find out if something's going to float? It does help, but it's the relationship between how much something weighs, and the biggie here is its volume. To determine if something will float, you must know the density, not just weight. That's a big misconception, so make sure that that is in your notes too. Alrighty, at the end of every PowerPoint, we also have your great set of terms for you. And we'll talk about this more in class tomorrow. Have a good night.